Lesson 7.1 is applying exponent properties involving products, and we know that a product is what we get when we multiply, and the parts that we multiply are called the factors. So here, notice what happens when you multiply two powers that have the same base. Let's review just a little bit. When you have an exponential component, you look at the base is, in this case, the a, and then the 2 is the power, or the exponent. So here I have a squared times a to the third. Well, I have a times a for a squared, and then a times a for a to the third. So altogether I have a to the fifth power, which is what I get when I take 2 plus 3. So when you have the product of a power, or product of powers, you just keep the base and you add the exponents. So here, let's go ahead and fill this in. Let a be a real number and m and n be positive integers. So positive integers, 1, they can't be negative, and 2, they can't be rational numbers. So to multiply powers having the same base, you add the exponents. So let's go ahead and fill this in right here. For example, a to the m times a to the n is a to the m plus n. And for 5 to the 6 times 5 to the 3, we have the same base of 5. The exponents are 6 and 3, so you're going to add those, and you get 5 to the 9th. I'm not going to make you show the addition because I think that you're capable of doing that. So let's go look at these examples. 5 to the 4th times 5 to the 8 is 5 to the 4 plus 8 is 12. Negative 10 to the 5th times negative 10 to the 2nd. Notice the negative 10 is in parentheses, so keep it in parentheses. 5 plus 2 is 7. 2 to the 5th times 2, this is to the first power. If there is no power, it's not a 0. We'll talk about 0 powers in another lesson. So this is 2 to the 1st. So 2 to the 5th times 2 to the 1st times 2 to the 4th. 5 plus 1 plus 4 is 10, so it's 2 to the 10th. Next we have another scenario. It says, notice what happens when you raise a power to a power. So we've got a to the second to the power of 3. So this means we have 3 factors of a to the second. And if you look at this, now this takes us back to our product of powers. A to the second, a to the second, a to the second is a to the 6th. So in other words, all we're doing is a to the 2 times 3. So that's where we're getting a to the 6th. And that's what it's going to show us down here. To find a power of a power, you multiply the exponents. So fill this in. A to the m to the power of n is a to the mn. We're multiplying. So 3 to the 4th to the 2nd is 3 to the 8th. Okay, let's do a couple of these. 3 to the 5th to the 2nd is 3 to the 10th, 5 times 2. 15 to the 2nd to the 4th is 15 to the 8th. 13 times 19 to the 4th, we're going to go ahead and do, the power of video. Notice that those two problems just disappeared because I had them in the wrong spot. So you will actually come back and finish those in a little bit. But we're going to go to this one down here. Negative 4th to the 5th to the 9th. Negative 4 is in parentheses, so keep it there. And it's negative 4 to the 45th. Here's where those other two problems belonged. So we have noticed what happens when you raise a product to a power. I have a times b to the third. So that's really 3 copies of ab, a times b. So this gives me, if I take this off, I have a times a times a, and b times b times b. So let's take this off. Whoops. And then that gives me a to the third, b to the third. So it almost looks like we're distributing the 3. Technically it's not the distributive property because to distribute you would have addition or subtraction within the quantity, but we are putting the 3 on every factor within our quantity, or our product in here. So the product of the power of a product. To find the power of a product, find the power of each factor and multiply. So here it is, algebraically. a to the b, or I'm sorry, a times b to the m is a to the m, b to the m. So this is why I deleted those problems before, because this is what it actually looks like. 23 times 17 to the fifth is 23 to the fifth times 17 to the fifth. And we're just going to leave it like that. All right, as you can see, those problems just miraculously showed back up. So it's going to be 13 to the fourth times 19 to the fourth. And you just leave it that way. Here it will be 135 to the fifth times 8 to the fifth. And we're leaving it. That's the power of a product. We're going to do a couple more over here. So I have 2 times a times b to the fifth. So I have to do 2 to the fifth, a to the fifth, b to the fifth. So I have to take it to every factor within my multiplication here. So 2 to the fifth is 32. We can go ahead and simplify the number. And then a to the fifth, b to the fifth. Here I have 2x to the third, y to the sixth. So I have 2 to the sixth, x to the third to the sixth, and y to the sixth. Notice right here, this gives me the power to a power as well. So 2 to the sixth is 64. X to the third to the sixth, remember we multiply, so that's x to the 18th, and then I have y to the sixth. Let's try another one. Here we're combining a few things. I have 3m to the seventh to the fourth times m to the third. So let's go ahead and take care of our power to a power here, product to a power. So I have 3 to the fourth, and then m to the seventh to the fourth, and then I still have times m to the third. So 3 to the fourth is 81, m to the seventh to the fourth is m to the 28th, and then I still have times m to the third. So now I have the bases of m here. This is 81, and remember when you have the product of powers, you add them, so 81m to the 31st. Let's try this one. I can't do anything with the 4p squared yet until I take care of this. So I have 3 to the second, and then p to the fifth to the second. So 4p squared times 3 to the second is 9, and p to the fifth to the second is p to the 10th because we multiply. Now I can just multiply my constants. 4 times 9 is 36. P squared times p to the 10th is p to the 12th. And then here they want us to find the missing exponent. So I know this is the product of powers right here. So x to the 6 times x to something has to equal 12. Well, I have to add these, so this has to be a 6 because 6 plus 6 equals 12. Here, 4 times something has to equal 12, so it has to be the 3. And here I'm looking for a 27z to the 18th. Well, 3 to the third is where I get my 27. And z to the something times 3 has to be 18, so this has to be, whoa, a 6. Okay, that's it for these notes, and I will eventually put the assignment up on the website. I'll actually probably just give it to you in class tomorrow.